An important concept to know is the number of types of carbon or types of hydrogen. Take a look at ethane. Ethane has 2 carbons. We draw it like this, 2 carbons. 1 carbon there, 1 carbon there. But even though it has 2 carbons, they are the same type of carbon because they are related by a plane of symmetry and also by a rotational axis of symmetry. If I take this and spin this molecule around, spin this atom over to here, that atom over to here, you end up getting that same molecule. So these 2 carbons are the same type. That means if we were to add another carbon to this, if I add a carbon to this to the right side, I get this. Or if I add a carbon to the left side, I get this. Now, either way I add a carbon, I get the same molecule, propane. So ethane has 2 carbons, but only 1 type. Let's take a look at propane now. Propane has 3 carbons. But if we look, carbons A, B, and C, carbon A and C are related by this plane of symmetry or also by this rotational axis again. If I spin it around, spin C to where A is and A to where C is, B stays the same, I get a molecule that looks the exact same as it was. And so propane has 3 carbons, but it only has 2 types because carbons A and C are the same type. So if we add a carbon to C, we get this. Or if we added a carbon to A, we get this, which is the same. But if we add a carbon to B, we get a new molecule here. And so basically now we have 2 molecules. These are the 2 isomers of butane. Let's take a look at these. Butane has 4 carbons, but again, due to symmetry, you can also, if you spin this molecule around, D becomes A, B becomes C, C becomes B, and so on, and A becomes D, and so on and so forth. Spinning that molecule around, you get the exact same thing out of it. So A and D are the same. B and C are the same. And so if we add a carbon to A, we get this. If we add a carbon to B, we get this. 2 different isomers. These are isomers of pentane. If we keep in mind that butane has that other isomers that we didn't use, here we have 4 carbons, A, B, C, and D. But if you look here, even though there's 4 carbons, we only have 2 types. Because we have a 3-fold axis of symmetry. If we spin A to C, C goes to D, D goes to A, and we get basically the same molecule back. A, C, and D are the same type. And so if we add a carbon to any of those, we'll get the same molecule, like so. B is a different type. So if we add a carbon to B, we get this. Now, we have, therefore, on our pentane isomers, we have drawn 4, but if we look at these two isomers, these are the same. So pentane isomers, there are 3 of them. Now let's take a look at pentane. We'll just look specifically at this particular pentane isomer. Here we have 5 carbons, A, B, C, D, and E. Even though we have 5 carbons, we actually have 3 types of carbon. Again, by symmetry, A and E are related to each other. B and D are related to each other. And C is left on its own lonesome. So here are basically the 3 types of carbons in pentane. We have A, B, and C. And so if we add a carbon to any of these, we'll get different isomers of hexane. Now if we take a look at this pentane isomer, we have, again, 5 carbons. But we only have 1, 2, 3, 4, 5. A and C are actually the same type of carbon. We have 4 types. And the last pentane isomer has only 2 types of carbon.